Hi guys, I am Vivek and this is Exposed. Today with another exciting video. Optics. This is an exclusive field where it's just light and applications of light. The basics of optics is some of the principles which light follow universally, such as reflection, refraction, diffraction and others. All these principles have some basic rules which they follow. To formulate these rules and understand, we usually use Newtonian calculations, but light itself disobeys basic rules of Newtonian physics. So today, in this video, I try to explain the real reason why light behaves as light behaves. To determine this, we use probability and vectors. I have explained the basics of these types of calculation in my previous video. Please check that out. I will explain the basic rules, what we follow, and move on to the working principles. Rules. The probability of an event is equal to the square of the length of an arrow called the probability amplitude. An arrow of length 0.4 units, for example, represents a probability of 0.16 or 16%. For drawing arrows, if an event can happen in alternative way, draw an arrow for each way and then combine the arrows by hooking the head of one of the tail to the next. A final arrow is then drawn from the tail of the first arrow to the head of the last one. The final arrow is the one whose square gives the probability of the entire event. These are the basic rules. Now we will see how the basic principle of reflection, that is, the angle of incidence is equal to the angle of reflection, can be explained using this technique, which is used to do all the other quantum calculations. We have a mirror, a source S, a detector P, and a screen between the two. For the angle of reflection to be equal to the angle of incidence, the light has to strike the mirror at the middle. But here we don't assume anything before starting the experiment. So the outcome should be this. According to the rules I explained earlier, if we draw an arrow for every outcome, we get this graphically. Mind you that we are considering only a ray of light for a unit area on the surface of the mirror. The more the data, the accurate the results. So when we see this graph and add the arrows together, the arrows right to the central part will cancel out the arrows to the left. All we are left with is the arrows pointing towards the same direction, which is in the center part of the mirror. If we examine this closely with proper amount of data, we will get a particular ray which reflects. Now moving to refraction. This happens when light travels from a lighter medium to a denser one. Now if we build a similar type of system with a source and a detector and plot the graph of the outcomes, we get this graph and the arrows respective to those positions. Here, if we observe the part where the arrows point in the same direction, is where the light takes the shortest path to reach the detector. And this is the path where refraction takes place. It's all about time. Light always takes the path with the least amount of time. If we apply this similar method, we can also explain mirage formation. Now we will see how the result of a lens is explained. Let's take the converging lens for example. Consider a source and a detector as usual. These are the possible paths light can take. But as I made clear, the only path the light takes is the shortest, and that is a straight line. Now, to make photons go through all the paths, we want to trick light. What we should do is calculate the deficit of time for every path in comparison with a straight line. But the other thing we know is that light travels slower in denser mediums like glass. So when we place a slab of glass in the path of straight line, the light takes a longer time to travel its course. So now we have to just place the right amount of glass in the path of light so that everywhere the path takes the same amount of time as the longest path. Then we have this outcome. This is just simple quantum physics, but the applications are various and this is the way things are actually working. All the other effects of light are actually working on the lines of these explanations and not on the Newtonian ray optics. From reflection to Big Bang, the basics are the same. This is Exposed and I am Vivek. See you in the next video. Peace out.